Good morning, everybody. Welcome to today's webinar on Trimble TX Series Tips and Tricks. Everybody is in listen-only mode. You can enter questions at any time in the chat field or the question field throughout the webinar, and we will save at least 15 minutes in the end to go through questions. I'm going to turn it over to Greg Jackson to get started.
Hello everyone, my name is Greg Jackson. I am the product manager for the Trimble TX6 and TX8. Thanks for joining us today for this geospatial webinar on Trimble TX tips and tricks. Here is an overview of the content we'll cover today. The goal is to provide information on work processes that will help you improve productivity, scan quality, and functionality with the TX scanner. I will provide details and/or tips and tricks on the following topics. And we'll start by discussing the scan modes. It's very important to understand this. The TX6 and TX8 scan modes are basically identical, with the only difference being the scan times and the additional scan mode of extended range for the TX8. Selecting the right scan mode is key to ensuring scan quality and productivity. The scan mode you choose should have sufficient density or point spacing for your application, whether you're scanning simple surfaces like walls and buildings, or more complex objects like valves and piping in plants. The distance to the area of interest will dictate to some degree the scan level required, but it is not the only consideration. Level 1 or Level 2 is the recommended scan mode for most applications when you're doing full 360-degree scans. The density is sufficient for building and civil applications, and it's good for plants where your scan range is typically 2 to 5 meters. If you need high-density data for more distant objects, like a tall utility pylon or a cell tower, then Level 3 area scans should be considered. But you should also consider the number of scans that will need to be taken to effectively capture the required details. You can increase density from overlapping scans and get better overall coverage by scanning from different perspectives. And you should always consider the scan time and file size to maximize productivity in the field and the office. Now, this table will give you a more clear picture of the point spacing that can be achieved at different distances. And the point spacing shown in the TX user interface for Level 1, 2, and 3 is for a range of 30 meters. And this table extrapolates those values so you know the spacing at shorter and longer distances. For example, when you get a 22.62 millimeter point spacing at 30 meters with Level 1, the point spacing at 5 meters is 3.77 millimeters. And for those of you that think in English units, that's a little less than 1 inch compared to approximately 1/8 of an inch. For Level 2 and Level 3, you can achieve the same 3.77 millimeter point spacing at 10 and 20 meters. And knowing these values can help you better determine what scan mode is best for your application and the distances that you're going to scan from. Now, I want to stress that when scanning complex objects, you typically get more detail from multiple overlapping lower density scans. Multiple scans can provide good density, and collecting data from different perspectives can give you better overall coverage than taking a few number of higher density scans. The total file size and scan time will typically prove to be more productive as well. For comparison, the file size and scan time of 3 Level 2 scans versus 1 Level 3 scan shows the total file size is smaller and the scan time is slightly less. Now, you would need to account for additional setup time, but setups normally don't take longer than a minute per station. And overlapping scans can also fill in areas that are not captured on highly reflective surfaces. When scanning areas like these stainless steel enclosures, it is common to have a blown out area in the point cloud when the laser scans directly perpendicular to the reflective surface and the return signal is too strong. And here are a couple of examples where an overlapping scan from another position filled in areas that were not captured from the first scan. And overlapping scans can also help when you're scanning black surfaces, when the return signal is too weak. It is common to only collect data when the laser is more perpendicular to the surface. And as the angle of incidence decreases, you will stop getting a return. Here is an example from scanning a black tank where an overlapping scan fills in the data on the right side of the tank that was not captured with the first scan because of the angle of incidence. And now for a tip that will effectively give you a level 2.5 scan mode if you have a TX8 with extended range. You can start an extended range scan, and after the first pass, you can stop the scan to save a standard 120 meter scan with a point spacing between level 2 and level 3. And the scan time is only 5.2 minutes compared to 10 minutes for a level 3 scan. Level 2 is the scan mode that I use most often because it only takes 3 minutes and you get good density. But I can certainly see using this trick to get even better density at 30 meters in only 5 minutes. Now, target acquisition is another consideration when determining scan modes and target placement. RealWorks requires a minimum of 200 points on targets to detect them for automatic registration. This table shows the points on target that you can get at various distances on 100 and 230 millimeter spheres and 150 millimeter black and white targets. The fields in green show the distances where greater than 200 points are captured. Now, if targets are not automatically detected, you can manually add them with the Target Analyzer tool. Highlighted in yellow are targets with greater than 20 points, which should allow you to create additional targets once they are located visually. You should keep these distances in mind when you're planning your stations and target positions. And remember, you must have a minimum of 3 shared targets between stations with good spacing to ensure accurate registration. Now here is another trick called ghosting targets. If you ever have to scan something with a minimal amount of targets, ghosting will come in handy. Consider you only have 3 spheres. You can position the 3 targets around the first station and capture a full 360-degree scan. Move the targets around the location of the second station and make sure they're at a distance where they can be captured from the first station. Capture an area scan of the new target positions from the first scan station. And then move the scanner to the second station and capture a full 360-degree scan. And you can continue repeating these steps for the remaining stations, and you should have no problem with automatic target-based registration as long as the targets are within distance and they're acquired with at least 200 points. Okay, next we'll go over area scans. Many of you may have already used area scans today, but I want to make sure everyone understands how and when to use this feature to add detail, save time, and minimize file size. Area scans are highly recommended when using level 3, high precision, or extended range because you only add density, precision, and range where you need it. Area scans can also be used to ensure target acquisition at longer distances. A full 360-degree scan with associated area scans are managed automatically. The TX groups full and area scans from the same station, and RealWorks automatically processes and groups these scans from each station. Parameters for the full scan are set from the main scan parameters screen. The scan mode is typically set to preview, level 1, or level 2. Area scans are set from the full scans preview screen after it's captured. Using area scan parameters, the scan mode is normally set to level 3, high precision, or extended range. And I'll go over all the steps for how this works. And for this example, we'll cover the steps to capture a full level 1 scan with HDR color and a level 3 area scan from the same station. You must first capture the full 360-degree scan, so you would pick the scan parameters from the main menu. Just set the scan mode to level 1 and then enable HDR color acquisition. You would start the scan, and when it's complete, it will be displayed in the preview screen. And then next, you would create the area scan. You could pick the Options button and then pick the Boundary button. This will allow you to adjust the vertical red lines to define the horizontal boundary of the area scan. You can use the Zoom button to zoom in on the full scan preview to see more detail. And this is helpful if you were needing to locate targets, for example. Next, you will pick the Scan button to go to the Area Scan screen, and pick the Scan Parameters button to set additional parameters. You could then set the scan mode to level 3 and enable HDR color acquisition. If you do not enable color acquisition in the area scan, then it would be displayed in grayscale intensity when it is viewed with the full colorized scan in true color. And note that this is also where you would enable high precision 4-pass with the TX8, for example. And you can pick the back arrow button to return to the area screen, and then pick the Scan button to start the scan. The area scan displays in the preview screen when it's complete. It's important to note that the TX8 automatically performs a single phase scan when collecting area scans, even if the dual face is enabled by default. You don't have to manually enable the single face mode. This is done automatically for area scans, so you only capture the area of interest. Both scans are stored under the same station. If you look at the project, you will see stations listed showing the number of full and area scans that are included. You can select the station to see the details on each scan. In this case, one full level 1 scan and one area level 3 scan. If an instrument height was set for the TX8, it would appear here as well. And the color icon on the preview indicates that color was acquired. When the scans are processed in RealWorks, they are listed under the associated station. And here is an image of the scans displayed in true color in the corner where the area scan was taken. And this was just taken here in my office. You can see use the scan color display to more clearly see the location of the area scan. And most important, if you zoom in on the border of the area scan, you can see the difference in the scan density that was captured. So you can understand in different applications where you could do area scans to capture higher detail on areas of interest, whether it's a control valve manifold in a plant, or whether it's detail on a utility pylon up high. And that's how you capture area scans. Now I want to mention a simple tip for doing quick area scans. Rather than doing a full scan and defining the area boundary from the preview screen, you can orient the scanner to the left of the area of interest. Start the scan and the scanner will rotate clockwise to capture the area. You can stop the scan once the area has been captured, and the area scan will be saved automatically. And you should tap yes when prompted to return the scanner to its origin. It will always do that whenever you stop a scan before it's completed. Now it's important to note that if you start a quick area scan from the main screen with the TX8, you should change the scan face from dual face to front face to only capture data from the area that you're wanting to scan. Otherwise, you will have additional data captured with the back face. Now, this is not a concern with the TX6 because it does not have a dual face mode. Okay, let's move on to talk about some of the TX8 high precision tips and tricks. The TX8 has a high precision 4-pass scan mode to achieve less than 1 millimeter range noise. These scans take 4 times as long as standard scans, but you can cancel the scan after the second or third pass to reduce the scan time and still achieve less than 1.4 millimeter range noise. This table shows the range noise you can expect from 2, 3, and 4 pass scans when compared to the standard deviation error and standard 1-pass scans. RealWorks will average the multi-pass scans when they are processed to reduce the range noise, and the merged scans result in a file size that's about the same as a standard scan. The TX8 high precision mode can also be used to reduce noise in high traffic areas. To do this, you must manually create an empty text file named VK merge in the temp folder on the computer running RealWorks. When high precision multipass scans are processed with the smart averaging algorithm to average the points from all the passes, and when the VK merge file is present, an additional operation will be initiated. If there is a 15 millimeter distance between a pair or group of points, only the most distant points will be kept. Closest points are assumed to be caused by traffic and removed if they cannot enhance the standard error of the most distant points. So try this the next time you're scanning on a roadway or an urban area where the traffic is an issue. And remember, you can also use the scan pause function with any of the standard scan modes to reduce noise in high traffic areas. Now I would like to talk about minimizing leveling. The TX6 and TX8 have the same survey grade dual axis compensator as the Trimble S-Series total stations to ensure the instrument is leveled accurately. But there is a misconception that leveling is required at each station. This is probably because we enable the dual axis compensator by default when the scanner is started, or that some scanners like the Leica P30 and P40 require all stations be level. The fact is, the only time that leveling is required is when you're measuring the height of the TX8 for basic survey workflow. For pure scanning workflows, we only recommend leveling one central scan in each logical group of scans. For example, each floor of a multi-story building. You can disable the dual axis compensator for the remaining scans in each group to save time in the field. The leveled scan will be used as the reference scan for registration in RealWorks, and the unleveled scans will be aligned to the reference, so the overall project will be leveled. Just make sure you have sufficient common targets or planes from station to station to accurately register the scans. And here's a quick tip for scanning buildings and using plane-based registration. You should scan in each doorway to maintain common planes when scanning from room to room. This will ensure RealWorks auto-register using planes will find enough common planes in your scans to automatically register. For civil, topographic, or corridor surveys of large areas, you may choose to level all the scans so that any scan could be used as the reference scan. And there will likely be more distance between each station. These projects may also employ total stations for survey control to orient registered scans. Total stations may also be used to survey monuments and targets in large plant projects to orientate the registered scans to a plant coordinate system. In general, leveling depends on your application and your workflow. It doesn't hurt to keep all stations level with the dual axis compensator enabled, but minimizing leveling can improve productivity in the field and simplify workflows when it's not required. Next, we'll go over some color acquisition tips and recent processing enhancements in RealWorks 10.3. First, let's review the internal camera. The camera was designed to provide fast image capture, taking just 1 minute for standard single exposure images and 2 minutes for HDR triple exposure. It's the fastest image capture of any scanner really on the market. It's a 10 megapixel camera that takes 6 or 18 full field of view pictures for each station. RealWorks automatically colorizes the point cloud if a TZF scan file has an associated TCF color file. No panoramas are created for the images. When you view scans in Trimble Scan Explorer, you are viewing a colorized point cloud only, not a panorama. So the only points that are captured are displayed. For example, you will not see imagery from the sky on outdoor scans. There is also an image scan parallax because the camera is lower than the center of the scanner. Some captured points may not be seen by the camera, and in this case, a grayscaled intensity is displayed for those points instead of color. Also, original images are not saved with the project, and there is no option to manually create panoramas, similar to the way that we do it with our external camera kits. Now, improvements have been made in RealWorks for processing TX images. In RealWorks 10.2, you could see a banding effect from different exposures in colorized scans. Here are examples from 10.2 of standard and HDR images with both auto and fixed exposure enabled. RealWorks 10.3 has eliminated this banding effect by normalizing and balancing the exposures. We recommend upgrading to 10.3 if you have not already done so to realize this improvement. And I found that the best results are from the HDR fixed exposure. If you compare these images here, the glare from the window is minimized and you get better clarity, for example, on the piping above the ceiling tile by the window. It looks a little lighter than the HDR image that used auto exposure. Now, fixed exposure uses the exposure from the first picture taken and applies it to the remaining pictures for a more balanced exposure in the scene. This mode is also recommended outdoors in bright sunlight. If you have varying degrees of bright and dark areas in the scene, then HDR auto exposure may provide better results. Standard can be considered in areas where lighting conditions are moderate and consistent throughout the scene. For example, indoors with no windows or possibly outdoors on an overcast day. But in general, I recommend HDR with fixed exposure. Now, color acquisition, distance, and resolution is important when you want to see fine details from the colorized point cloud in Trimble Scan Explorer. There are distance resolution limits, and I want to show a series of images from the same area that are taken at different distances to clarify these limits. And just to be clear, these are from Trimble Scan Explorer where you're viewing single scans. Now, the objects from 2 meters have sufficient resolution to view finer details. In this example, the scan is from approximately 2 meters, and you can clearly make out details like the domestic hot and cold water labels. And if I zoom in further, you can even see the smaller domestic hot water return label. Now, the labels actually look sharper in TSE than they do in these images, but hopefully you can get the idea. Now, this example is from approximately 3.5 meters, and the larger labels are still clear, but the smaller label can no longer be read. At 5 meters, you can still make out the larger labels and the piping detail, but they are becoming less clear. And at a distance of 8 meters, you don't have sufficient resolution to read the labels when you zoom in. Just as scan density and distance is important to capture detail on complex objects, distance and resolution is important to consider for color acquisition. Don't expect to see high resolution detail from every distance in Trimble Scan Explorer. And remember to scan from 2 to 4 meters when there are fine details that you want to capture with the camera. Now, when you view the colorized point cloud of the registered scans in RealWorks Examiner, you will see good detail of the same area we just analyzed in TSE. And in my opinion, the 3D point cloud is where it counts. In TSE, you just have to be selective about which scan you view in order to see the details from certain areas. Next, I want to do a comparison of the Gitzo tripod with the Trimax survey tripod to show some benefits that we've noticed when using the Gitzo with the TX scanners. Here are the physical specifications for both tripods. The Gitzo weighs 10 pounds less than the Trimax. It has approximately half the retracted height, and the extended height is just 10 inches less than the Trimax. So the Gitzo is much more compact and lightweight, making it easier to transport and move the scanner from station to station. The legs lock out for stability, and they have rubber feet for hard, smooth surfaces. And these rubber feet also work great on steel grating in plants. They also have spiked feet for less stable outdoor surfaces. The Gitzo offers the flexibility to address most applications, and it's easier to move with the scanner connected. and this simplifies field work and improves productivity in most environments. Trimax tripods are recommended for survey workflows when you're setting up over a known point and measuring the height of instrument. I would also recommend the Trimax for extremely rough or sloped terrain because it's easier to adjust the legs with the clamps. The Gitzo has telescopic legs that require both hands to adjust them. So both tripods have their place, but for pure scanning workflows, we recommend the Gitzo for its ease of use and flexibility in most cases. And I want to mention that we recently announced new TX6 and TX8 Gitzo tripod bundles, and there is a special promotion where you can get the Gitzo tripod for the same price as the Trimax when you purchase any of the kits shown here. This is a limited time offer through June 30th, so if you're interested in trying a Gitzo tripod with your next TX purchase, you may want to take advantage of this offer. And here's just a listing of the part numbers for these TX6 and TX8 kits. To close, I would like to do an application summary based on some of the topics we've covered. But first, a statement on TX8 and TX6 positioning. The TX6 is primarily reserved for building and forensics applications, and the TX8 is the most versatile, being able to support virtually any application. The TX6 can be used for the other applications listed, but only for smaller scale projects. For larger projects with a faster scan speed, 340 meter extended range, or high precision can be of benefit to you, then the TX8 extended instrument would be the model of choice. Okay, so concerning the full scan modes, level 1 and level 2 are my go-to scan mode for full scans, and some applications may also require extended range scans. I also like the idea of using the level 2.5 when you need higher density full scan without the extended range. The area scans, you're going to use level 3, high precision, extended range. They're the most commonly used. For targets and registration, buildings in urban areas can rely solely on plane-based registration, where other applications will require targets and possibly survey control. HDR is the recommended color acquisition mode, and I prefer the results that I get when I use fixed exposure. The Gitzo and Trimax tripods are listed where they are most applicable, but this can vary in some instances depending on the terrain, and that's why I have them both listed for some of these applications. So that's just a very general application summary based on some of the topics that we discussed today. And with that, I would like to conclude this webinar, and thank you very much for your time today. Please let us know if you have any questions.
Greg, are you able to see the questions?
I am. Yes, I'm expanding it right now. Let me look. Okay. I'm working on it.
Do you want me to go ahead and read you a few?
Yeah, I'm looking here. Okay, I realize that the scan station number is really just a container for the scans collected from a position, but will we ever be able to rename this station number in the field to correspond with the survey point number that we may be able to set over, rather than working with the default naming convention and matching up point numbers later in RealWorks? Yeah, right now, no, there is not a way to set that in the field in the TX8 interface. So that is something that we can certainly pass on to the developers to try to add that to the firmware. Okay, and then what scan modes would you use to scan road surfaces for inspection purposes? I would suggest that you know, it certainly with the TX8, you know, you could use the extended range mode in order to capture larger areas at a single scan, but I would recommend the level 2 scan mode. I think that that's going to give you certainly sufficient resolution, and you'd be able to quickly capture the area. Level 1 would probably give you sufficient density as well. So level 1 or level 2 would be the recommended modes for that. And can you please explain the advantage of target ghosting? I wouldn't say that there's an advantage to using ghosting. It's just more of an emergency type of application if you did not have enough targets in your possession at the time that you're trying to scan something. Maybe you didn't get all of the targets that arrived at site, and so you're limited with the number of targets that you have. And so ghosting is just something that you could use in an emergency. It's certainly easier to have a greater number of targets so that you can set up targets around maybe 3 scan positions that you're going to work from. But yeah, I guess you know, the only advantage to ghosting is that you can do it if you need to. Can you quickly review how to manipulate the averaging done in TRW when importing 2-pass scans in traffic to reduce noise? There's nothing that you can do to manipulate the way it's processed. All I can tell you is that it does the smart averaging, and that if it sees that VK merge file, then it's also going to run a second process to detect if there are if there's more than a 15 millimeter distance between any pair or group of points. And then at that point, it's going to remove the closest point and keep the most distant point. So it will assume that the closest point is created from noise. But yeah, there's no way to manipulate how that averaging is actually done. It's all automatic and happens behind the scenes. What noise filtration options are there in RealWorks? Mixed pixel, edge effects, isolated points, etc. I would have to defer that question to Jason Hayes, and unfortunately, he's the product manager for RealWorks, and unfortunately, he was unable to make this webinar today, and so I would not be able to effectively answer that question at this time. I apologize. what speed of road travel for level 2? Well, it's the TX6 and TX8 are not currently not really used for mobile applications, so you're not going to have any kind of ability to track the movement of the scanner down a roadway. It's not a mobile scanning application, so we really don't support that at this time. I would suggest that it's certainly something that I've asked to look into, because the speed of the scanner to me would make the TX6 and the TX8 an excellent mobile scanning scanner for mobile applications. Can we automatically include target ID in the control file import open?
Real quick, Greg Jackson, because that's a three-part question. He says, Richard said, can we automatically include target ID in the control file import open for georeferencing and outliers?
Okay. Yeah, I'm not certain on that question. I'm sorry. I'm not sure how to answer that. So that's a three-part, you said?
Yeah, and then he said outliers we're adding to the noise question. Richard, I can give you Greg Jackson's email, and you can reach out to him directly.
Yeah, that would be best, and then I can maybe get some assistance with that answer from someone else. Okay, area scans. You have vertical lines. Can you define a box? Currently, no. You can only define the vertical lines to define the horizontal boundary. So, point taken, but yes, currently you cannot do that. Is the traffic removal mode in TRW 10.2 or only 10.3? That should work in 10.2 as well. So as long as you add the VK merge text file to your temp folder, you should be able to use that in 10.2. Okay, it looks like that's all of the questions. Do we have any more? Did I miss any?
We don't.
It is in really small text on this. So okay. Well, thank you very much, everyone. And if you have any more questions, feel free to email me direct. My email address is Greg, Gregg _ Jackson @trimble.com. And thanks again for your time today. I hope it was helpful.